Well, as I said that we have three parts. The first part contains the basic of a number system and its conversation and the presentation in computer. And the second and third part are binary and decimal floating point arithmetic respectively. So first of all, let's introduce ourselves with the number system. Once I want to talk with a number system, the first of all I have to tell the system that we are using in our real life, which is decimal number system. Let's take the laser. Okay, so decimal number having 10 symbols and each symbol called the digits. As the base is 10, so I will show you how the number is calculated. Here the number 735. So last significant digit is multiplied by 10 with the power of 0 here. And the next digit is multiplied by 10 with the power of 1, and this is increasing every digit by 1. So when you do this, you will get the number. This is the way we calculate decimal number. Similarly, the binary numbers that all of our modern computer use having only two symbols, zeros and ones. Why computer use this number system only zeros and ones? Because computer use the electronic component that have only two states, on and off, or zeros and ones. This is an example of a binary number. 10110. B is for binary. Yeah, like the decimal one earlier, here we have to do the same thing. That means we have to multiply the bit with 2, and the power will be start from the 0 to increase 1 by 1 until the most significant bit. So here the last significant bit is 0, so we need to multiply 2 and the power will be 0, and then the second bit 1, so we have to multiply 1 with 2 and the power will be the 1. Similarly, the power of these 2 is increasing 1 by 1 until the end of the digit. This is the way the binary represents. So let's move the last one, hexadecimal. It means it's a 16 symbol. So on top of 0 to 9, it having additional A, B, C, D, E, and F, and we called it the hex digit. For example, here A3EA is a hex number. How it comes from? Like the 10 in decimal, 2 in binary, here just put the 16. So the first power 16 will be the 0, then 1, 2, and 3. So this is the way we calculate the number system. So, and any other number system, you can create your own number system with the one weight and one number of symbol. Alright? Okay, so these are the relationship among hexadecimal, decimal, and the binary. So first thing that you keep in mind that all are having the same objective, to count something. This is the number are used to count something, right? Okay, and another thing is these are the 6 hexadecimal. There are 16 symbol. So each hexadecimal symbol need to represent in binary. We need 4 bit and 2 decimal digit maximum. Okay, and the A, B, C, D, and E and F are 10, 11, 12, 13, 14, and 15 respectively in decimal. Okay, so these are the relationship among these three number system. Okay, so now as we have many number system in our real world, we use decimal, and some programming language they are using hexadecimal, and finally the computer use binary. So in every aspect we need to convert from one format to another format. So there are several ways an algorithm to convert the binary number to decimal number and other. So here is a common example that we can convert the decimal number by binary number using the successive division by 2 method. Okay, we have to divide by 2 and examine the remainder, and then the quotient is again divided by the 2 and check the remainder. So this is the way we calculate. Once you reversely convert to the decimal to binary, you have to multiply its binary number with 2, having the power of 0 the last position and starting from the right of the digit. Increase the power 1 by 1 with the base as I told you early slide, and then sum up all product in decimal number. You will get the conversion from the binary to decimal. So to get an example, let's move to the whiteboard. Say 75. So we will convert this to the corresponding binary number. So what we have to do, just simply divided by 75 divided by 2 is equal 37.5. I mean 37, and the remainder is 1. And then this 37 comes again and divided by 2, and we will get 18.5. That means 18, and then remainder is 1. Then this 18 divided by 2 is just exactly 9, so our remainder is 0. 9 divided by 2 simply is 4.5, so remainder is 1. 4 divided by 2 is 2, and the remainder is 0. And finally 2 divided by 2 is 1, and the remainder is 0. Okay, that's it. We got the result, and here is the most significant bit. So, and then followed by this. So we will get the 1 from here, and then 0, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1 is the binary number. Okay, so we have now this number 1, 0, 0, 1, 0, 1, 1, 2. Okay, so now let's move and solve it for the decimal. Okay, so what we have to do, you have to take this number again here, 1, 0, 0, 1, 0, 1, 1. Okay, so here you are, it will be 2 to power the position 0 to 1 to 2 to 3 to 4 to 5 to 6. Let's calculate this number. So here you are, here is 2 power 0 is 1, and then 2, 0, 2 to the power is 8, and then 0, 0, and 2 to the power 26 is 64. So let's add this number together. So you will get the result is 7510. So these are not very complicated thing, just as I am studying, and this is very important in computer cases, because computer basically convert all the numbers in the binary number, and within various aspects inside the computer we need this type of conversion. Here is the integer arithmetic. So the first thing I would like to share with you, that is the result of an integer arithmetic is also an integer. Okay? So as in the next part 2 and part 3 we will discuss the floating point arithmetic, that having a part of integer significant or coefficient. So right now we don't need to discuss detail about the integer arithmetic. So that's the end of the first part. That means within the number system, we are discussing about the integer part, and the rest of the part we will discuss about the floating point, and within floating point we have binary and decimal. Okay, so thank you for having interest in this content. In next part we will show the floating point representation for binary arithmetic.